All right, guys. Wanted to give you my take on this mess, on just the 1.4 homework. So here's my take on a few of these. There's several questions that are roughly the same kind of variation. And so I wanted to at least show you a few of them. My take here on question one, if I saw something like this, let's see here, annotate that mess. Oh, boy, that'll work. Okay. I'm noticing that they give me an angle right here. This is our 20-degree angle. Since that's the angle that we're given, that's the one I'm going to focus on. Not to say we couldn't figure out an angle over here, they all add up to 180, it's whatever. But if this is our angle, that'll help us out. And so what I'd recommend is if you're trying to solve out parts of a triangle here, I would start by labeling up the pieces with respect to the angle you're looking at. So if this is our angle, when we know, of course, we're talking about opposite and adjacent and hypotenuse, let's just label them up. At least label up the sides that they give you to work with, You'll notice that this side doesn't, it's the opposite, but it doesn't seem like we use that one. There's nothing really there for us. So that may or may not be something you want to do. You could write opposite if you want, or don't bother. It's whatever, because it's not really helpful, but it looks like, okay, if that's the opposite, then we're stuck with this being, of course, this is the hypotenuse because it's not part of the right angle. It's across from the right angle, however you want to say it. And then this must be the adjacent if it's not the opposite, touching the angle or whatever. So we have adjacent and hypotenuse. And the reason that's beneficial is because now that's going to tell us through Sohcahtoa what in the world angle ratio or trig ratio to use here. And so let's remember how that goes. Sohcahtoa. If I'm looking at this, I have adjacent and hypotenuse. That's A and H. Adjacent and hypotenuse means it's coming from the C ratio, that's cosine. And so cosine must be our guy. So we'll say, here, I won't write the whole thing. We'll just do cosine of some angle is what's going to be used here. And so remember how that goes, though. We'll say cosine of our angle, which we don't have a name for, but we know the measure of it, So we'll just say cosine of our 20-degree angle equals the adjacent over the hypotenuse. That's what cosine does. And fortunately, we have some info about the adjacent and hypotenuse. The adjacent is x, don't know that, but the hypotenuse is 12, we do know that. And then they just want us to see if we can figure out, well, what is that missing number, Fortunately, we're good at algebra and we have our calculators around to be able to help us with the trig part. And so let's see here, if I do that, let's see, I can get the x by itself by pretty much timesing the 12 over here, because x is on top of the fraction, so it's not much of an issue this time. And so now we can just say, well, times the 12 over there, it'll be 12 times that. And that's our x by itself. We have 12 times whatever the cosine at 20 degrees is. Make sure your calculators are in degree mode. They will probably be by default. But you'll notice that if you keep getting the wrong answers, it's perhaps because they're in radian mode. Anyway, if I put that in my calculator, 12 times cosine of 20 degrees, I'm getting a little bit over 11 here, 11 point, and it's got all this mess, 2, 7, 6, 3, 1, 1, la, 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 more stuff. But you'll notice the directions on these ones tell us we just got to round off after the hundredths place, or 2 spots past the decimal. So this would be 11 point. It would be 27, but of course that 6 is going to round the 7 up. So we're looking at roughly 11.28 here is what it looks like. And then it'll be similar for, I got all these noises going on. It'll be similar for all the other problems in the first few here. Let me clear off all those drawings here. And let's get on to the next mess. Oh, I'm still annotating. Hold on. Okay. So these next ones are very similar, 2 and 3 are very similar. It's just a matter of labeling up and catching the ratios. Here, we won't do the whole thing, but let's at least look at one of them so we can be at least convinced that we can handle them all the same way. So let's say we did number 3 here. We have an angle that's given up here, and then there's an x given down there, and then this thing over there. Well, we'll just label them. We'll say it's some kind of a ratio, Sohcahtoa, sine, cosine, or tangent will be beneficial for us. One of these ratios will help, and we'll label it up. That x is across from my angle that I'm focusing on. Here's my angle, so across from it is opposite. That'll be an opposite there. And then this is not the hypotenuse, so it must be adjacent. We're looking good. And so we have an opposite over adjacent, opposite adjacent. That must be a tangent ratio with the O and the A there. So we'll say it looks like we're going to use a tangent ratio at 42 degrees equals the opposite over the adjacent, and then we'll just label them up. This is an O and an A, so opposite is X, adjacent is 10, and it's looking pretty similar there. We have a 10 on the bottom, the X is on the top, so if we just times the 10 over there, we'll be good, and it'll be just 10 times tangent of 42 equals X. Only thing I would say here is, let's see here, do we have anywhere the X is going to be on the bottom? I don't see any just yet, but let's just take that on the diary for a second, because in hypotheticals, sometimes you get these things where, what if we had something that ended up like this? Watch this. So we had some sine ratio or something at 30 degrees, whatever, and then we're like, equals the opposite over the hypotenuse, right? Like sine ratio does. Again, remember, this is not to do with this problem or this problem. We're just in Dear Diary over here, because I'm predicting a situation that we haven't run into yet, and I keep on not seeing it in the homework. So, you may see it at some point in one version of your homework, or you may see it in a later section, but we will run into it at some point. What if we had the X on the bottom, and it was like this or something, where it was like opposite over hypotenuse. The opposite was 5, and the hypotenuse we didn't know, Well, if I want to get this by itself, where the X is by itself, remember, I can't just times 5 or divide 5 at this point. It's the X that's the bottom of the fraction. He's being divided. What I'd recommend at that point is just maybe let's just get rid of the fraction anyway, and we'll times the X out. Even though that doesn't totally directly get X by itself, it kind of helps us to be able to do that. Because now if I times the X over, now we have X times the sine of 30 equals 5. That's nice, because now I can get the X by itself because it's not on the bottom of a fraction. And we'll just say, well, if I'm timesing sine of 30, I'll divide it, and then we'll have everything we need. This is kind of a classic technique. Not the only way people do it. There's even shorter cut ways that you could figure out if you want. Nonetheless, we got X equals then 5 over the sine of 30, and that's where you just shoot it into a calculator. And then whatever 5 divided by sine 30 is, make sure you're in degree mode and you'll be all right. That's kind of how something like that would go if you run into a situation where X is on the bottom of your ratio. That does happen sometimes, so watch out for that. We clear those off, and I wanted to show you something else going on here. Okay. Oh, still annotating. Okay. Numbers 4 and oh yeah, let's do it number 4 and 5. So number 4 here, what I'm seeing is we have a couple of sides given, but what is being asked of us is to find out an angle measure, not to find a third side or something like that. That would be Pythagorean Theorem if they wanted that. But if we have to figure out what is the measure of this angle here, we'll call it X or something like that. I don't know. Well, kind of what I recommend is just keep doing the same old thing. Is we'll just figure out, label things up with respect to the angle we're staring at, which is this one. And then once we get all things labeled up, Sohcahtoa will tell us what ratio to use. And then once we get ourselves worked into a corner, we'll figure our way out. Check this out. Okay, so here's the angle, and then opposite is over there. That's not helpful to us because that's neither one of the sides they gave us. But there's the opposite. So this is hypotenuse because it's across from the right angle again, right? That's hypotenuse. And this must be adjacent because it's not the opposite, nor is it the hypotenuse. So it's good. Okay. So scribble. Anyway, so we have adjacent and hypotenuse. We're back to a cosine ratio. A and H is a cosine ratio, it looks like. So we're going to go cosine. And then here's the thing. Normally we say cosine of whatever angle equals the adjacent over the hypotenuse. And we're still going to do that. And we just don't know how many degrees it is this time. So we'll say cosine of whatever angle. I just don't know what it is now. And we call it an X or an A or an alpha or a theta or something weird. And then adjacent over hypotenuse, let's see here. That's going to be adjacent is 11 and then hypotenuse is 13. At least we don't have any missing numbers over there. This is nice. So now we have the cosine of some angle gives me 11 over 13. And that's not real obvious how to do that. And so what you might remember is normally we get to say, well, the cosine of some some angle right here. So cosine 20, cosine 42, like we did on those last couple of problems. And that's something you can shoot into a calculator. Good luck telling your calculator to do the cosine of something you don't know, you know? And so this is where we'll actually have to use an inverse version of our cosine. We used to use these by tables where we'd look stuff up in a trig chart backwards. But in this case, what we can do is we'll say, oh, if it's backwards, well, we're going to have to ask the calculator to kind of reverse phone lookup it, you know? And so it's going to be, we'll say, okay, dear calculator, what I want you to do is run what we call an inverse cosine. And so oftentimes it's written like this, inverse cosine with little -1 power there of something. And that's where we're say inverse cosine of 11/13, meaning I want you to figure out what in the world angle gave us a cosine ratio of 11/13. That's what this does, you know? So if you're trying to cosine something you don't got, what you can do is instead inverse cosine the output. And then, you know, if you view it as a function or something like that, then really the output is now the input. And then we can say, and that will give you the X value that you came from, you know? Some calculators will call this arc cosine. So you may see it written like that. Instead of inverse cosine, there's different ways of seeing it. Anyways, shoot that into a calculator and you get everything you want. Let me see if I can run that real quick without being boring for you guys. Inverse cosine of 11/13. I believe I'm still in degree mode. Should be about 32 point something, 32 point whatever, 0.20 pretty much. And what that means for us guys is that's the angle measure that cosine does to at 11/13. So this is actually not drawn too poorly off scale. Not that, I mean, I don't think they tried to draw it to scale, you know. Anyway, we're looking at 32 point something degrees is what that means. So the way we could read that is cosine of 32 degrees equals roughly 11/13. You know, 32 degrees is the angle we were looking for in the first place. That cosigned us there. Anyway, that's kind of what that's about. Let's see here. Clear that up, annotate. Similar. Then we get a few word problem things going on. Not too big a deal. What I'd recommend for these ones is draw them as you go the best that you can. And so let's see here on, oh, whoops, trying to move the screen there. Oh, I guess we're doing number 7. So we have a 28-foot ladder leans against a building. Okay, so here's a building, ladder's leaning against it. You know, I don't know how tall the building is or anything like that, but I do know the ladder is 28 feet long, 28-foot ladder. So this ladder length is 28 feet right there. And then it's leaning against the building. So the angle between the ground and the ladder is 84 degrees. So here's the ground, here's the ladder. That means this must be 84 degrees, I guess, you know, 84 degrees open door right there. I didn't quite draw that right. It should be a little bit more uphill to be an 84. That's almost 90 degrees. You know, this guy's straight up trying to stand on a ladder like this, you know, like pretty extreme uphill, you know, almost 90 degrees. Maybe not the best idea. Anyway, how high how high does the ladder reach on the building? So we're wondering, well, how high up the building does that hit? If it's a 28-foot ladder, you got an 84-degree incline here. How high up is that? You know, you can put a question mark, you can put H for height if you want, or since we use that for other stuff, you could just put X if you want, whatever you want, or put a Y since it's an up and down thing, or W for wall, or, you know, whatever you want. Put a letter, and then let's just, from there, we're going to recognize that this is a right triangle, and we'll handle it the same way. This is the ground. This is the building. They're making assumptions here that we're building on flat ground, or that we have flattened ground to be able to build on it. It's kind of a flat slab, not accounting for like the 1/4 inch per foot that has to fall or anything like that. And then now we'll say, well, I recognize the angle. That's the angle we're focusing on. Let me change colors here. If that's the angle we're focusing on, then every side that we label will be based on that. So we're looking at over here is across from that 84 degrees. That must be the opposite. So this X unknown is our opposite. And then this must be the hypotenuse because it's across from the 90, or it's the slant one or the big one or whatever. And so that's our hypotenuse. Now by Sohcahtoa, that's opposite and hypotenuse. So that will be a sine ratio. Remember, Sohcahtoa, opposite and hypotenuse comes from the S ratio or the sine ratio. And so then we'll say, okay, sine of 84 degrees, got the degrees this time, that's nice. Sine of some angle equals the opposite over the hypotenuse. And so opposite don't know it, hypotenuse we do know is 28. Looking good. And then we can just handle it like we did the ones earlier because the X is on the top. We'll probably just times the 28 over there and be good. So this will end up being just 28 times the sine of 84 degrees. Shoot that in a calculator and you'll be as good as gold. Be careful with your rounding, of course. Make sure you're rounding well after 2 places. Okay, let's see here. What else? Let's move along. Oh yeah, that stuff stays here. Let's clear that junk off. And then we see some applications near the end here. There's another, looks like a couple of word problems. We'll talk about those, but another couple of applications that involve solving a right triangle where they give you a couple of pieces of information here, and then they ask you just to figure out everything else that you can, you know. And so if they give us A is 6 and little c is 12, let's go ahead and do that. Little a and little c, those are sides, you know, we use capital letters for the angles. So let's see here, this is 6 steps up here, and c is 12 steps there. And we're wondering, can I figure out the other side? Can I figure out these 2 angles here? This one I know is at 90, so they're not going to ask me for that one probably. So let's see here. First off, you guys know, if I have 2 sides and I want a third one in a right triangle, I can just go Pythagorean theorem. So that's easy enough. This little b part we can get is just b squared plus 6 squared, or 6 squared plus b squared, if you want to be perfectly in order, equals 12 squared, you know. A squared and b squared makes c squared. And so then we run the numbers on that, you know, that'll be 36 and 144. And then from there, you kind of know how it goes. We'll minus the 36 out, whatever the heck that is, you know, something 100, whatever. And then we'll square root it to get the b by itself here. What is that going to be? 14 minus 6 is 8. So then that's going to be, is it just 108 or something? That sounds right. Yeah, must be. And so then from there, get the b squared by, or whatever. Pretend like I said it right. Get that squared out of there. And then we got just the square root of 108, looking good. And then on this one, let me see. It doesn't tell us where to draw this, or where to round it off on this one that I see. Oh, it says to 1 decimal place. So that's good. So shoot that in a calculator. It should be 10 point something, and then make sure you round it carefully. It'll be 10 point, you know, something. Make sure you go at least 1 place past that decimal, like they're saying. And then for the angle parts, remember, for angles, we're going to have to use trig ratios here. And so if I saw this, we have a 6 and a 12. And then you'll notice what's weird about this one is they don't really tell us what angle to focus on. And well, I mean, that's kind of going to be up to us. We might choose to focus on angle A when we're figuring out angle A, because that's kind of, you know, what the point of that part is, you know. So I'm going to go ahead and, at least for angle A here, we'll say I'm going to focus on this being the angle. And if that's the case, then I'll label the 6 and the 12 that they gave me with respect to this angle A. And so if this is the angle I'm looking at, that's across from it. So 6 is opposite, and then 12 must be the hypotenuse because it's across from the right angle. Opposite over hypotenuse is sine ratio by Sohcahtoa. So we'll say sine of some angle A I don't know equals the opposite over the hypotenuse. Opposite over hypotenuse is 6 over 12 in this case. Opposite hypotenuse. And then we're in this same pickle before where we're like, dear calculator, sine of and then you're like looking for a letter A or whatever, your calculator can't do a sign of some letter for you. It needs an input there. So if it can't do that, that means you must need it to handle this thing backwards, and reverse look it up. So here we're going to say sine inverse it. I want you to figure out what angle gave me that 6/12, you know? And so we'll say, well, let's figure that out. We can do that. The inverse sine of 6/12 will tell us that. And so inverse sine of 6/12 will tell us what angle A gave us that in the first place. Then you just shoot that in a calculator. It'll give you some number of degrees. And then that'll be here. I'll go ahead and do that one real quick. Clear. And then inverse sine of 6/12, which by the way is a half. I mean, you could just put a half if you like. Anyway, and that'll equal exactly 30 degrees. There's no rounding to deal with on that one because it's so nice. Anyway, and so this makes that a 30-degree angle. And now if you want to, guys, there's different ways of approaching this. Now that that's 30 degrees, we know that this was 90 degrees and that's 30. Probably the easiest way to get angle B here would be just to make sure that they all three add up to 180. So 90 and 30 makes 120. The only thing left over is like another 60 degrees here. So we could pretty much just say, I figured that this was 60 degrees up yonder by just figuring from classic geometry stuff, you know, angle sum theorem. But if you don't like that, it's okay. What you can also do is figure that out. I'm not going to right now, but you could certainly figure that out by making B the angle of focus and then using your 6 and 12 in the same way and being like, well, this is adjacent and hypotenuse now, and then you'll get, by Sohcahtoa, you'll just be running a cosine of B equals 6/12, or in other words, running an inverse cosine of 6/12, and that'll get you your 60 degrees that way. Anyway, that's what I'm looking at there. Clear that mess out. Boom. And then let's see here. Find the height of the building. Okay, angle of elevation. Let's do that one quick because I wanted to talk to you guys about the area of the triangle thing, because I want to give you an intuitive perspective on that one instead of just using a formula, like a foreign formula. We'll bank on what we know about geometry. And so, but here real quick on number 10, I'll at least get you started on that one. Let's see here. Okay, angle of elevation to the top of a building in New York is found to be 2 degrees from the ground at a distance of 2 miles from the base of the building. So we are 2 miles out. I'm going to put 2 miles for now. And then we are looking at an angle of elevation, meaning like if I were standing here or landing on the ground, I would have to tilt my head up 2 degrees, 2 degrees to be able to see the top of that building from a couple of miles away. Okay, now find the height of the building. Notice, okay, they're giving you all this weird stuff about this. There's a hint here about 1 mile is 5,000 something feet. And that's because, you know, they give you information in terms of miles. And then when they ask you to find the height of the building, they want to know it in feet. And so what might be an easy thing to do is instead of dealing with miles here, we'll just say, well, 2 miles away is also 5,000 something times 2, you know, and so if we just times that by 2 on the side here, I believe that gives us 10,560 feet. And that way, even before we do any figuring, 10,560, that's a number of feet away that we are. Put a little hyphen thing for feet. Or what do they call that? It's not a hyphen, who cares? Anyway, apostrophe looking deal, it doesn't matter. But now whatever figuring I do will be in terms of feet already, and I won't have to worry about converting it later when it's already funky looking. Anyway, they just want to know what's the height of the building, so you approach it in the same way. These numbers are just more extreme, very small angle, very big number across town, you know. But again, to at least kickstart you on this, here's the angle. So that's looking like an opposite and an adjacent to me, you know, because opposite is across from the angle that we're focusing on. That's our 2 degree angle right there. Across from it will be opposite. And then this is not the hypotenuse. It's part of the right angle to the ground. So that's the adjacent. So I'm thinking opposite and adjacent. That's a tangent ratio by Sohcahtoa, if you'll remember. So, Let's just pretend you can read that. TOA stands for tangent ratio being opposite and adjacent here. That's our guy. So then we'll set that up basically the same like those other ones. It'll be a tangent ratio of some degrees. In this case, 2 degrees equals the opposite over the adjacent, or x, over 10, 5, 60, as long as I times that right. Then you just times it over there and get the x by itself and call it a day. I mean, I know I'd make this look simple. If it's troubling you, it's okay. I just don't like to make the videos too long, that's all. Anyway, so also find the area of a triangle with sides of this and this, an included angle of 64 degrees. Let's talk about that for a second. Okay, in blue or whatever. It has side lengths of 13 and 22 and an included angle of 64 degrees. So what we're talking about here, guys, is, okay, here's some triangle. Say this is 22 and then the other one is 13. And then I'm going to try and draw this a little bit to scale. They say that 64 degrees is the included angle, which means between the 13 and the 22 is 64 degrees. Now I'm going to draw my 22 to be a little bit bigger than the 13. Okay. And then once you have that, you're like, well, it's a triangle. So I'll draw my 22 big. Then there's 64 degrees, should actually be probably a little bit taller than that, but whatever. And then 13 should be shorter looking than the 22. I feel like I have a decent drawing here. And then I'll just connect the dots. Now it looks like a triangle. They want us to know the area of it. And there's a bunch of ways to do this. But what I always lean on is going back to classic geometry stuff. What we could say is, remember, and there's reasons for this because it's like half of a rectangle or however else you want to look at it. But remember, area of a triangle area, oh my goodness, triangle area equals, you'll take the base times the height and then do half of it, or divide it by 2. 1/2 times base times height, or just base times height, take half. And so that's what I intend to do, is we'll figure out, well, how far across is the base of this thing, which we know because they told us 22. And then how tall is the height of it? We don't know that. But if I can figure out that, then I'll just do the base times the height, and then I'll take half of it. And so let's see here. Boom. The base, well, here, let's fill in what we know. The base we already know is 22. Base. The height we don't know. We'll have to figure that out. That's where trig comes in, and then we'll divide it all by 2 when we're done. And so we'll be good. So let's see if we can figure out how tall that height is. And so I'm just going to draw that straight up. Defining a base and a height here means that they're sitting at right angles to one another. So here's my base. If I draw 22 as being my base like I did, and again, you can twist this around and draw it in any direction you want. But if I consider 22 to be my base, then my height will be straight up at a right angle from that. And there's our 90 degree. And that means we're starting to see some right angle stuff happen, right triangle stuff, And so we can do a little bit of trig here. I would put H for height, but I hesitate to because of the whole hypotenuse H thing. So we'll just put like, an X again, I guess, and we'll just know that that stands for the height this time. And so let's see here. If this is the angle we're given, we'll focus on that angle and we'll label up everything we have with respect to it. And so let's see here. I'm hoping to figure out this side. And so check this out. It looks like we're kind of kid in a candy store here because we got options. And I guess that's not really what the whole kid in a candy store analogy is about, is having options, but whatever. There are options in a candy store. So what I'm noticing is this is the side that I want. And so if I label that with respect to my angle, it's right across from it. So that looks like an opposite thing. So I definitely want to use a ratio that has an opposite in it. But then I also have, I could be looking at, well, should I look at the bottom or should I look at this up here? And actually what we'll find out is that it's not as beneficial as we think to use the bottom, because look at this. I'm looking at this. I'm like, is the base 22? Well, not this part, not in my right triangle. So I guess 22 is not helpful because that's this big old 22 across there. It's not really part of the right angle I'm looking at. I don't know how much of that 22 is over here. So we're probably stuck with using this 13. And so in this right triangle, it looks like the 13 is the hypotenuse, So now we have opposite and hypotenuse here. By Sohcahtoa, opposite and hypotenuse, Sohcahtoa. Oh yeah, that's opposite hypotenuse. That's sine ratio stuff. So we'll say sine of 64 degrees equals the opposite over the hypotenuse, in this case, the x over the 13. Times that 13 over there to get the x by itself. And we got ourselves x equals, or sorry, yeah, x equals, or height equals 13 times the sine of 64. And that's what goes in for our height there. So we'll just pretend like I can fit all that in there. 13 times the sine of 64, let's rewrite it over here. So we have 22 is the base, times the height ends up being 13 times the sine of 64 degrees. And then it's base times height there, and then we'll divide it by 2 and call it a day. And that should give you everything you need on that, and then just round it off when you're done. It's okay if you want to reduce the 22 over 2 into an 11 right off the bat or something like that, totally fine. Or else just shoot it all in a calculator and don't worry about it. Here, I guess since I got you guys, I'll go ahead and figure that out real quick. Let's see your dear calculator. Sine ratio. No, we don't need it. Well, let's do 22 times 13 times the sine of 64 degrees. And then we'll divide all of that by 2. And I'm getting about 128 here. So it is tall. I guess with a 64-degree angle, it's believable. It's a little bit higher than I figured it would be. Let's see here. But it's all there. I don't think I made any mistakes. If somebody finds out a mistake I made in that, let me know. Maybe I punched into the calculator wrong. It's just a little bit higher than I was estimating it to be is all. But whatever. It's a 64-degree angle, so it's believable. Anyway, so now we got round to the nearest tenth. And so it looks like about 128.5. Oh, duh. And we're not figuring out the height. We already knew that. We're figuring out the square footage here. So the area, yeah, about 128.5. That's believable for sure. Whew. Okay, anyway, that's my take on how this mess should go. We're looking at an area, not a height, an area of about 128, 129 square units. Okay, let's see here. Done, done, and done. Stop the share. Like stop the recording or something. Oh yeah, there you go.